How to resize image file created with DD. I have a DD image from a 4GB SD card that has two partitions. These two partitions are only using up about 800 MB, and as such I wish to reduce the size of the image file. Does anyone know of a way to remove the free space from the image file?
First, make sure the free space is actually empty and doesn't contain leftovers of deleted files. With recent kernels, 3.2 or later, it's easiest to do so by mounting each partition of the loop image, then issuing a discard using ftrim on the mount point. This works on loop devices in a similar way to trim on SSDs. Unused areas are replaced with zeros and the underlying .image file becomes sparse. Otherwise, an easy way to achieve this is to create a huge file on the disk, containing only null bytes, then delete it. Then compress it with a tool like zip or XZ. Even at lowest compression levels, a long series of zeros will compress well. Note that you must uncompress the image when writing it back to disk. This will uncompress it live. Note that the output device, SDA, must be of sufficient size to fit the original image, otherwise data will be lost or corrupted. An alternative method, if you want to keep using the image, for example with a virtual machine, is to convert the raw image to one of the image formats used by virtualization software, for example CO2 for QEMU, VV for VirtualBox, or VMDK for VMware. Note that this still requires you to prepare the image by cleaning the free space using the above method. But if it's going to be written to a real disk again, you have to convert it back to a raw image.
Using resize to FS is much easier. You will be asked to E2FSEK first, so image must not be mounted. Note, this will only work if the image is of a single partition. If it's a whole block device with mutable partitions, see above answer.
I originally posted the same answer here, on Stack Exchange Ask Ubuntu. I repropose the same answer here, it can be useful. The key information was the use of the command truncate. Following the full solution in order to not lose the answer. A preliminary step consists in cloning the SD card in your PC. Use lsblk to see which devices are available and if their partitions are mounted. Unmount all partitions of the device you want to copy on your PC. For example, create a copy of the whole SD card with all the partitions unmounted. Shrinking images on Linux. Context of the problem. Having a myimage.img bigger than the hardware support. If it is smaller, there should be no problem. However, using the same strategy, you can better fit the image in the hardware support. The secret is to use standard Linux tools and instruments, parted, fdisk and truncate. Requirements. A Linux PC. The .img you want to shrink myimage.img in this example. Creating loopback device. Parted is an application typically used to manage partition tables and file systems. In order to shrink the image, parted is going to be used along the first part of the answer. Parted operates on devices, not simple files like images. This is why we first need to create a device for the image. We do this using the loopback functionality of Linux. Let's enable the loopback. Let's request a new, free, loopback device. The command returns the path to a free loopback device. Let's create a device of the image. The device /dev/loop0 represents myimage.img. We want to access the partitions that are on the image, so we need to ask the kernel to load those too. This should give us the device /dev/loop0p1, which represents the first partition in myimage.img. We do not need this device directly, but parted requires it. Resize partition using parted. Let's load the new device using parted. When the parted application opens, it should appear a window similar to the following. Now notice a few things. There is one partition. The partition allocates the entire disk/device/image. The partition is filled partly. We want to resize this partition so that it fits its content, but not more than that. Select the partition and click resize/move. A window similar to the following will pop up. Drag the right bar to the left as much as possible. Note that sometimes parted will need a few MB extra to place some file system related data. You can press the up arrow at the new size box a few times to do so. For example, I pressed it 10 times, equals 10 MB, for FAT32 to work. For NTFS you might not need to at all. Finally press resize/move. You will return to the parted window. This time it will look similar to the following. Notice that there is a part of the disk unallocated. This part of the disk will not be used by the partition, so we can shave this part off of the image later. Parted is a tool for disks, so it doesn't shrink images, only partitions. We have to do the shrinking of the image ourselves. Press apply in parted. It will now move files and finally shrink the partition, so it can take a minute or two, but most of the time it finishes quickly. Afterwards close parted. Now we don't need the loopback device anymore, so unload it. Shaving the image. Now that we have all the important data at the beginning of the image, it is time to shave off that unallocated part. We will first need to know where our partition ends and where the unallocated part begins. We do this using FDisk. Here we will see an output similar to the following. Note two things in the output. The partition ends on block 9,181,183, shown under end. The block size is 512 bytes, shown as sectors of 1 times 512. We will use these numbers in the rest of the example. The block size, 512, is often the same, but the ending block, 9,181,183, will differ for you. The numbers mean that the partition ends on byte 9,181,183,512 of the file. After that byte comes the unallocated part. Only the first 9,181,183,512 bytes will be useful for our image. Next we shrink the image file to a size that can just contain the partition. For this we will use the truncate command. Thanks UGLA. With the truncate command need to supply the size of the file in bytes. The last block was 9,181,183 and block number start at 0. That means we need 9181183 plus 1, 512 bytes. This is important, else the partition will not fit the image. So now we use truncate with the calculations.
I also tried it with Camus image, and it worked like a charm. We are resizing the test.image to make it 2 grams, 2 GB. Worked flawless for me.